Hello, and welcome. Today we are joined by, let's name him Steve. Steve is a blue Sour Patch Man pop. He's adorable, right? Okay, division of exponents. So we worked with multiplication of exponents and parentheses last week. You should have reviewed that Monday. And today we're moving on to division of exponents. Arguably, probably one of the hardest ones to understand, but one of the easiest to do once you get it. Sorry, there are lots of cords at my feet. So, we'll do a couple examples today, and then you'll get to try a couple examples and a worksheet at the end of this lesson. So, division of exponents always starts with a fraction, always. So we're going to start with x to the fifth over x to the fourth. Okay? So, x to the fifth, remember, I have a fancy ruler so it can be all nice and straight. Let's get that nice and straight on there. Perfect. Okay. Extend a little bit over. There you go. So x to the fifth is x times x times x times x, and when we expand it, and x to the fourth is x times x times x. That's 4 x's and 5 x's. Expansion is done once you've done this. Nothing else needs to be done. Now for the actual simplification. What you're going to do is, I'm going to rephrase that. If I had 5 over 5 and I divided that, what you should tell me is that 5 over 5 is 1, because any number divided by itself is going to equal 1. My eraser is gone. Oh well. That works the exact same for variables. So x divided by x equals 1 as well. So what I'm going to do is going to find all the cases where I have x divided by x up here and cross them out, because those are just going to equal 1. And you. So this is x over x, x over x, x over x, and x over x. So each one of those is just equaling 1. So I have 1 times 1 times 1 times 1 times this little x over 1. Now, anything multiplied by 1 is, hopefully you said itself. So really these do absolutely nothing. So we're just left with x over 1. And anything divided by 1 is the exact same as multiplied. It does nothing. So what we're left with is x. Or x to the first power. Does that make sense? I'm going to focus on this really highly during this. What I want you to pay attention to is pay attention to the end exponent, and pay attention to the original exponents. Is there anything I can do to 5 and 4 to get 1? Think about that. We're going to do another example. Okay. In this case, I want to show you what it looks like when I have a bigger exponent on bottom, because that does change a couple things around. Let's say I have x to the 7th over x to the 10th. I know I just signed myself up for a lot of writing, which is why I am recommending you guys figure out a quicker way than expanding, because expanding only really works when you're dealing with things that are under 10. As soon as you have exponents bigger than 10, you don't want to write out 100 x's, or 20 x's really for that matter. So I have x times x times x times x times x times x times x. That's 7 x's. And then x times x times x. That's 5 x's. There you go. Now I have 10 x's. So we're going to do the exact same thing as last time. We're going to cancel out all the ones that are over each other. So x over x, x over x. These all die until one side runs out. So what I'm left with is I'm left with 3 x's on the bottom, which leaves me with 7 times 1 over x to the 3rd, because I had 3 x's. Okay? Again, these do nothing, so really, if you're comfortable with this idea, you don't have to write these anymore. That just equals 1 over x to the 3rd power. Does this make sense? Okay, again, I want you to pay attention. Look at the end exponent. Look at the starting exponents. What can I do to 10 and 7 to get 3? Okay? We're gonna do another one. By the end of this little mini lesson, I'd like you guys to be able to see that whichever side has more, that is where the leftover x's are going to end up. Okay? This time though, because we've been working with x's, let's try working with 5, for instance. Okay? Just like multiplication, I can't do anything if my bases are not the same. If this is 5 over 4, I literally can't do anything. Okay? Let's say, like that. Let's make it nice and easy on us. See if I can draw a straight line by hand. Is it straight? It's kind of straight. So, I have 5 to the third over 5 to the second. I want you to take a guess right now. Put it on a piece of paper. Top or bottom? Which one do you think is going to be left over with extra x's? Hopefully you've written that down. Let's expand. Okay. Cross out ones that are the same because 5 over 5 just equals 1. I have 1 times 5 over 1. That does nothing, and I'm left with just 5 on top. Okay, if it doesn't have a 1 over it, it's on top. So if you guessed there would be extra 5s left over on top, you were correct. Let's try another one. And this one, I'm actually going to use multiple variables. So I have x and y. Let's say I have x to the great question. What should I have x to? X to the, let's say 6. Y to the third power. Now, do I have the same basis? This is where I stare at you like Dora and go, you can do it. If you said no, you were correct. I don't have the same basis, which means I literally can't do anything. So this ends up being x to the 6th power over x, y to the 3rd, and nothing can be done from there. Okay, that was your intro to division of exponents. Keep going, and I'll show you what to do when I have multiple bases and multiple exponents in one fraction. Say bye, Steve. Bye, Steve.